4, 3, 2. Welcome back. We are INFR3110 in the fall 2020 semester at Ontario Tech, and it's Game Engine Design and Implementation, Lesson 2, Part 2. We're talking about game engines this time around. So in the previous video, we were talking about UML diagrams. We did a very, very high level of flowcharts, as well as pseudocode. And again, you'll see more of that happening. I'm just going to turn this off. You'll see more about pseudocode and flowcharts in your tutorial. So let's talk about game engines again. Lots and lots of different kinds of game engines we're going to be talking about in this one. We're going to be talking about different kinds of engines and what are they good for. We're not talking about architecture yet. That's for a future lesson. All right, so let's talk about what game engines are. If I was going to say what a game engine is, and I asked you guys that last time, it's some kind of framework for creating video games without the need to create all the systems. Why? The system has been either pre-created for you. There's an infrastructure that's there that you can use to create a game with. So it's ready to go. Some really popular ones, and you can get this from this little link right here. You can see this is an updated link, by the way. You can see that from a leader perspective, Unreal and Unity are way over here. Notice that over here, again, market presence. You can see from a market presence perspective that Unreal and Unity are almost neck and neck. However, when it comes to satisfaction towards the right, people seem to be more satisfied with Unity than Unreal. So Unreal is just a step back in terms of satisfaction. There's a reason for this. Even though from a market presence and usability perspective, Unreal perhaps is a little bit more used in the industry than Unity, the challenge is when it comes to Unreal that it has a learning curve, much higher learning curve than Unity does, and that gives this, it kind of pushes satisfaction back just a bit. So again, you can see that there's other technologies that are listed here as well. You can see that maybe not game engines, but you can see that Blender is up here as well. Blender. There was a Blender game engine at one point or another. Now I think it's been they've removed it from the latest version of Blender. Blender 2.9 definitely doesn't have a game engine in there. AWS Lumberyards, right? So again, that would be in Amazon Lumberyards would be up here. This Apple symbol represents Swift Scene Kit and AR Kit and Sprite Kit. Not really a game engine, but game frameworks that exist that are out there. And this is kind of a way of looking at, some more popular game engines out there. So if you actually go look for game engines, you actually go to this link here. It'll give you this little chart. All right. So what do you consider when choosing a game engine? Well, we want to consider a bunch of different pieces, right? So a game engine is made up of many parts. In your mind, it should be different systems. So audio-visual fidelity, functional fidelity, composability, developer tools, so how you can connect to a game engine. A good example of that is things like, there's no more Windows Phone, but things like iOS SDK, Android SDK, the Android NDK, which is something that you may want to deploy for mobile games. Accessibility, usability, as an example. How about the price? If it's really expensive to use that game engine, or if it's even accessible at all. If it's proprietary, that will put a stop to it. Networking, do we have networking right now? Unity, no. That's kind of a real big block for us to use Unity nowadays. You have to do your own networking. Development features, deployment platforms. Unity has, I would say, more than anyone else, more than Unreal. Unreal is pretty good, but Unity actually hits a bunch of niches as well. So what about engines versus APIs? What's the difference? And some people have this thing where they say, I want to use OpenGL, and they think OpenGL is a game engine. OpenGL is not a game engine, it's a 3D pipeline, but sometimes people confuse that. And sometimes we can use libraries instead of a whole game engine. For example, I might use the Create.js library or the 3JS library to create a game, right? I don't need a whole engine for that. I can build my own stuff out but I can use libraries to help me do some of the functions. For example, draw functions, let's say in JavaScript, a little easier, right? As opposed to me using lower level functions. So libraries sometimes are good to use too. A good example of that for C++ is the SDL library. It's not a game engine, but it gives you a lot of functionality right out of the box, as opposed to doing things with, let's say, WinAPI, which is really low level. There's a lot more to do with WinAPI. Okay, so again, some characteristics. We want to use game engines to manage game data, to coordinate data with subcomponents, manage the flow of data. Notice the data, produce visuals, and enable simple interaction with the user and player. So this is kind of some high-level characteristics of all game engines. All right. From a game engine perspective, most game engines are made of different engines, almost like plugins or components. I might have and most engines do, some kind of AI engine. Okay. My physics engine could be something I turn on, or it may not even exist. I may have to plug it in, all right? Or I can swap it out. For example, if I want to use bullet physics as opposed to ammo physics, different kind of engines, ammo.js, I'm thinking about it on the JavaScript side again, or bullet.js. There's different ones, right? It's the same thing with physics engines. I can use the Havoc engine as an example, or I can use the engine that's built into Unity, right? Unity has its own physics engine that's built in, but you can swap it out with something else. Graphics engines are typically tightly bundled or tightly coupled with the different game engines. Some game engines give you the ability for you to do 2D or 3D exclusively. So, for example, some engines they're exclusively 2D engines. Some engines are exclusively 3D engines. And some engines, even though they're exclusively 3D engines, can actually, create a 2D camera view, which make it seem as if they're 2D. Okay, but they're not. They're 3D. A good example of that one is Unity. And actually, the way we do blueprints for Unreal, they have something else, which is very similar to what Unity does, paper 2D. Okay, so that's kind of the way it's done. User interactions engine, that's also something that instead of an engine, it might be a system. For Unity, it's definitely some kind of event system. The newer event system is more abstract than the older one. And the same thing goes with the sound engine. You can actually plug in a sound system into Unity. You can use Fmod as an example with Unity or Unreal, as opposed to using the stuff that's built in. Unity has its own sound manager, but you can make it so it plugs in with Fmod, which might be a higher fidelity engine that provides things like spatial sound. So that's one thing you've noticed. I've talked about how we can swap parts in and out a lot of times, or turn on or turn off components. Not every game needs every component to be turned on. For example, maybe I'm making a game that's very simple where I don't need AI. Maybe it's some kind of puzzle game that I got to figure out, and the puzzle's just random. It's procedurally generated as opposed to using AI, like a full AI agent system. And here's an example of just going a little deeper. Let's say, for example, the sound engine. The sound engine may have specific capabilities that you're looking for. Some kind of ability to initialize and load, play the sound, shut down the sound engine. We might be able to store sounds, the sound data, some kind of a data ID for accessing the sounds. And I want to definitely give instructions from instances, users, play sound, stop sound, continue sound, make it louder, make it softer. All that kind of stuff will be involved in the sound engine. So each component, if you will, of the game engine should have almost like a mini API that we can tap into so we can use it. And it's actually true. If you look at Unreal or Unity, they have different capabilities for different components or parts of the system. I use the word component, but I want to think about them more because we're not talking about an ECS, an entity component system. I want to think about it more as systems. We have a bunch of systems or sections, if you will, or sub-engines, right, as opposed to maybe the use of components. If I say components, you might get the wrong idea. Let's take a look at the Quake family engine. All right, so the Quake family engine made a bunch of different kinds of sub-engines, all right, and sub-games. All right, so the Quake family made the Wolfenstein 3D. It made Doom. These are sub-engines, actually. They're actually created as a subsidiary of the Quake family group of engines, Quake engine, and so on. You can see that sometimes what happens is we have this hierarchy, right, where different games are made from a base engine. So an example of this would be, I have Unity, but I want to make my own brand of Unity. I want to extend Unity, and I want to add components to Unity so that, and I call it something else. And then when we make games in our little studio, we use our version of Unity. Actually, it's done more from an Unreal perspective than a Unity perspective. We take Unity or Unreal and we customize it and we make it our own. We call it some kind of engine. A lot of times also, a lot of these engines are homegrown. That means that they're written from scratch, right? Because they're there to solve a problem. We want to make a specific type of game, and it's not necessarily all games we want to write, just a specific use case. Example would be if I want to make something in VR. Maybe you'll only play in VR, and there won't be a need for some 2D components that you would have in other games. So that maybe we'd make an engine just for that. So ID Tech 1, I think, was one of the first ones that we can remember. And when you do a search, if you actually go to Books Ngram Viewer, you can see for a lot of years the term game engine itself didn't really compute. And especially from a Google perspective, there wasn't anything back then, especially since Google really didn't exist. But you can see how after 1990 or so, when the internet took off, you can see that there has been a great increase in the number of books and or searches that are related to game engines. This is the little curve that shows you, and this is up to date, by the way, from the earliest time that we had database online until the year 2019. So you can see how it just really, spiked over the last several years in terms of how many searches and how many books there are related to game engines. Tons and tons of them. But Doom definitely was one of the first game engines created, the ID Tech 1, which is one of the first engines ever created. So why do we use game engines? Reusability. We want to save some time. We accumulate know-how. I do something, as an example, it's almost like a part of my toolbox, if you will. I create new tools in my toolbox, new math libraries, new whatever, and then I want to reuse those things, but I get better at it. Maybe my math library is slightly better in Engine version 2, as an example, compared to Engine version 1. Or maybe my capabilities from a drawing perspective when it came to 3D graphics was better in the next engine because it included Vulkan support as opposed to only OpenGL support. So that's why we create game engines. And of course, we always look for what desired results we're looking for that particular use case. So here's an example of the Fox engine that was created 7 years ago. What did the Fox engine make? It made a bunch of different kinds of games. Metal Gear Solid is actually the one I remember back in the day. But there's many other ones that the Fox engine made from Kojima Productions. All right, so again, initial release in 2013, and look, they made a game called eFootball Pro Evolution Soccer 2020 in 2019. So it's still something that's alive today. Sometimes you'll look at an engine up on Wikipedia and it'll show you that it's completely dead. There is no more development for that particular engine. Why? Because we've moved on, right? We've moved on to different technologies. Maybe we're supporting a different platform. Notice this engine worked for it was proprietary, and it worked for PlayStation 4, Xbox One, PlayStation 3, Xbox 360, and a bunch of earlier versions of those platforms. So why bother reinventing the wheel? Why bother? Did I restart the YouTube live stream? Yeah, it started, but it's actually on a different connection. Why? Jimmy is asking me if I restarted my live stream. It started, it's just on a different link altogether. Don't tell me it's the same link. That would be bad. I'm pretty sure it's a different link altogether. Anyways, great. Let's get back to this. So why reinvent the wheel? Why even bother creating another engine. I mean, if you can use a commercial game engine out there like Unreal or Unity, then why bother doing it? Well, you want to develop skills. Interest would be one of the the reasons why people do it. You want to get a greater understanding of how game engines work. There's another reason for it. Maybe you want freedom, independence, and autonomy from developing games from Unreal or Unity. You don't want to pay royalties to Unreal or Unity or some other kind of game engine. You want to have all the money for yourself. The reason why Unity and Unreal make so much money is because people use them. Because making a game engine, my friends, is really difficult, especially if it's going to handle many types of games. But remember, I always go back to what Dr. Hogue always said to us when we first started, which was, make a game, not a game engine. And the game engine will come, because you're going to make another game, and you're going to use the same reusable components that you had from the previous game engine, right? And you're going to add to it, and add to it, and add to it. And that's how the game engine comes about. Not from, I want to make a game engine. Until you use it, you don't even know if those components even work. So until you have a use case, making components that could work for any game may not work for you, right? So it could be a waste of your time and energy. So that is why reinvent the wheel. Let's talk about other considerations when it comes to game engine. Again, let's keep in mind that we treat our game like a product or perhaps even a service. Consider who will use the game engine and how it fits in the development cycle. So think about that. Is it for, how do artists use your game engine? Are you going to be able to create some kind of level editor? And one of the things we're going to be doing this semester in one of the first group projects, and that's the first thing you're going to get, is you're going to make a level editor for Unity. That's the one first. And you're going to say to yourself, wait, I don't need a level editor for Unity. Unity is a level editor. Yes. But what if you had an artist who didn't know anything about Unity, and you wanted to just make him just create stuff? You just want him just to, to lay out the levels for you. He can select objects, almost like Mario Maker, right? As an example, drag and drop stuff into your screen live, right? And then save that level, maybe in the form of some kind of JSON data or something else that you can load up later on. That would be the exercise for assignment 1, and that's what's coming. You're going to see that. All I'm going to do is I'm going to break it up into 2 parts that you're going to see. It's going to actually be probably out tomorrow. And the first part is like, okay, I want to develop my base for Unity, and this is where I'm going to have Nicholas help you guys. So artists, so there's an example of something where I want to extend a game engine. So how would artists use my game engine? How would game designers use my game engine? Where do they fit in? As an example, is there something that the game engine does for them? How about producers? Is there a way of managing game development from, for the game engine itself? Not just about engineers, not just always about software developers. Take a look at something like Roblox. Roblox, which many people make fun of because they're like, oh my God, Roblox Studio, it's the worst game engine ever, and it makes terrible games. Guys, there are more Roblox users now than ever before. We're talking about millions and millions of users who use Roblox. And it's not something to laugh at anymore. Before it was like, meh, Roblox, it's like, RPG Maker or something like that. And people would actually not really be happy with it. Oh, I want to use Unity or I want to use Unreal. But now, Roblox Studio is becoming more and more popular. Why? Because of its ease of entry. Even kids can do it, right? Other considerations, like we talked about, render efficiently. We want to think about that. Some kind of good input for human interface, as an example. So I want some kind of human-computer interface. I want to be able to do that. Maybe it can reproduce sounds on its own, or it has great networking. Again, one of the things that Unity has a real problem with right now, where Unreal is better, is networking. Like we're talking out of the box. Software maintenance estimates. If this is interesting too. One of the biggest problem is that Unreal has millions of lines of code, right? Can you imagine? This is a good reason why you don't want to make your own game engine. You want to use a commercial game engine like Unreal or Unity, because think about all the work you have to do to maintain that thing if you want to give it to other users. changes in user requirements. Oh, I have to add this thing in. I might have an issue to fix, an emergency fix that I want to do. I want to do some kind of regular debugging because there might be some new feature that I put in. Hardware changes. All this stuff, by the way, is almost the exact same thing that happens for any application out there, because that, in effect, is what a game engine is. It's a tool that I can use, and the tool is constantly evolving and getting better and better. That's the idea behind it, and supporting more and more platforms and more opportunities to make different kinds of games. In the beginning when I first started using Unity, there's a lot of things that Unity couldn't do. Its particle systems were pretty not so great at all. Now Unity's particle system is pretty awesome. Particle system editor that's built into Unity. Before, when Unity did 2D animation, you were limited just to mechanism, right? Now they have Anima 2D. You can actually put bones on a 2D object, 2D sprites with bones, right? They added that capability. Before, there was no capability for the Unity engine so that you could do visual scripting. Now they've just included Bolt, right? So you can do visual scripting with Unity as well, not just Unreal. So you can see that they keep on adding more things, but every time they add a new thing, it increases the maintenance. We have to make some user changes. We have to do some debugging. There has to be some fixes. There's going to be some breaks and everything else. And that's why Unity has a very active release cycle. So can you imagine doing all that yourself? It might just be your job to be just an engine developer, and that's it. And if you like that, that's great. So here's some background of game engine. Again, we start off with the Quake family of game engines, and we learn from these things. We can see that as we move forward, it's not called Lumberjack, actually. It's called Lumberyards. I don't know why Lumberjack is here. It should stay Lumberyards. Here's something. How often have you heard lumberyards even being used nowadays, right? It's not something that you hear a lot about. You hear still a lot more about Unity and Unreal. But that's only because Amazon hasn't really pushed it, right? But you can see that there's definitely an evolution. That's what's happened, right? One group of developers, they move from one game engine into another one, and they make another iteration, okay? So you can get that from GitHub as well. Another great reason of making game engines is money. You got to figure out the global game engines market is, from a 2017 perspective, was a crazy amount of money. Why? Because so many games are being made these days. Remember that games are taking the place of movies in many ways, right? And I really believe in the future that there'll be less traditional movies that we have today. It'll be almost like a trip to go on to see a movie, as an example, in the theater, compared to playing video games. Video games are interactive entertainment. Movies, it's one way. And that's going to cater to some people. But I think more and more over the next several years, as our younger gamers today grow up, they watch TV differently. Right? They watch TV on demand a lot more than they used to. I didn't grow up like that. And a lot of my generation grew up waiting for the TV show to come out. And there's still examples of that. Examples of The Boys. They release, one episode every week, as an example. And why am I saying movies and I'm not talking about video games? Because it's the same thing. We're entertaining ourselves in many ways. Except for movies, I'm going to pay, and I think I've talked about this already, I'm going to pay $35 to get 2 hours of entertainment. Or I can pay $70 or $80. Example, I just got that Mario game today, right? For my little guy, and it's going to be hours of entertainment, maybe hundreds of hours of entertainment. The value proposition, from a video game perspective for the average player is very high, right? You get a lot out of it, unless it's some kind of lemon, like some kind of game that's an asset flip game that you bought on Steam, and then you're not paying a lot of money anyway. You might waste some time, but the idea is that you're going to get value from most games that you buy out there. The studios that are out there making games, they're not there to make just to make money and not satisfy the players. It's kind of hand in hand. Although sometimes I wonder how EA continues to operate the way they do. But at the end of the day, and I'm not going to go too much into that, but at the end of the day, when we think about this, the market is huge. There's a huge reason for us to continue to make games and for companies to make game engines so we can get more games into the marketplace. And remember also that people who resell games, resellers like Steam, right? The more games that are put on Steam, the happier Steam is. Valve, I mean, really, do they make games anymore? So, so here's some key players in the game engine business. Again, we talked about this: Unity Technologies, Epic Games, Crytek, Valve for sure is still a party to it, but they're definitely not as big as they're not making games as much. And there's other ones, okay? Corona Labs, Game Salad, and so on. There's a bunch of other kind of developers of game engines. There is a market for, I guess, split between 3D, 2.5D, and 2D games, which we've talked about already, and also on the basis of end user applications. PC games versus mobile games versus TV games versus car games. Now with the Tesla, you can play a game in your car with CarPlay as an example. There's so many options for you, and it creates different user stories, if you will, or different user scenarios for game engines, right? So it's not just about 3D game engines, but other ones as well. Okay. Major players in global and the United States video game market include, but are not limited to, Xbox, PlayStation, and a bunch of other ones. You can see some of them are not just hardware creators, but also content creators. Some of them are simple hardware creators. Turtle Beach, who hasn't had a Turtle Beach headset or a Turtle Beach audio card at some point? I mean, I know they've come up with a lot of them. Thrustmaster has come up with new joysticks now for Flight Simulator, the new flight simulator that's off by Microsoft, where they have different flight sticks that have come out. Really, really cool. And there's other ones. So you can see that the game industry has its roots all over in the marketplace. It's not just about the game engine, but offshoots from making games. So that's why it's so massive and so successful. And there's negative things about it too. Different genres that are being produced. And think about these. A lot of the genres that are here, that have been listed here, could you not think of each of these genres being a movie or a book? Right? So some kind of puzzle movie. Have you never seen that before? Some kind of driving movie, Fast and Furious. Some kind of simulation movie, The Matrix. Some kind of strategy movie, and we can keep going through this. And so movies and video games, there's such a relationship between the two. There's an analog between one and the other, right? And this means that a lot of the things that we've seen so far in the movie industry is coming down the pipe for the game industry. And a good example of that would be perhaps unions, with all the crunch that the game industry goes through right now. The game industry goes through a ton of crunch, and a lot of that is because of our agile project management processes that we'll talk about in future lectures. Let's get into the different kinds of game engines, and this is where I'm looking for your kind of input now at this point. So here's one, the 4A engine. You may have not heard about this, but it's made by the guys who made Metro 2033. Great little game, really popular. Scared the crap out of me, especially in the tunnels when I first played this game back in the day. It's an awesome game, and again, the 4A engine was the thing that made this thing. All right, proprietary. Okay, made in March of 2010, so that's like 10 years old, this thing. Okay, so I made this one in Metro Last Light. Gamebryo or Gamebryo is the way you're supposed to say this thing. Gamebryo, 23 years old, this thing. So it's been around for a long, long time. It's cross-platform, and it was made for things like Oblivion, Civilization 4, and a ton of other games that were made from Gamebryo, which is kind of a weird way of saying it. I think that's why they moved away from the engine itself and they moved into something else. Then they went into something called the Creation Engine. I think this is one of the ones they've used now for some of the later games. This is Bethesda now that have been using this thing. So the creation engine is also proprietary. It's used for Fallout 4, Skyrim, and probably going to be used later on for their next Elder Scrolls game. Maybe it's going to be another version of the creation engine. I like it and I don't like it. Some parts of the creation engine, you know what? When I think back to the previous engine that was used, to make Oblivion and to make things like Fallout 3 New Vegas and all those kind of things, there's a lot of things that I really like about this engine. I really do. And even the way it renders graphics and everything else, is a different look and feel to it than what we get with Fallout 4. Fallout 4 gave us great graphics, but the biggest problem with Fallout 4, or even some of the other games that were created with this thing, was the story. Red Engine. This is something, if you want to try and find Red Engine on Wikipedia, you won't find it exactly. We'd have to go to almost like a fan site where they kind of talked about CD Projekt Red and their Red Engine. It was created back in May of 2011, it says in French, and it supports various different platforms. So Red Engine. Okay. I think, again, it was, for what it was able to do, you got to figure it's a proprietary engine that's made by these guys to tell a story, and specifically was made for The Witcher. Fallout 76, we're not going to talk about Fallout 76. We don't talk about Fallout 76 on my channel. I don't do that. Fallout 76 is a big disappointment. Okay. Star Wars Battlefront 2, right? Again, DICE. I would say, kind of an on-again, off-again type of developer. I like DICE for the stuff that they've done. But DICE being owned by EA, I just somehow think, and by the way, they're anything to do with Battlefront. I mean, when it comes to this, the Frostbite engine is probably one of the most popular engines out there from a proprietary perspective that's being used by subsidiaries of EA, right? They've created fantastic games, fantastic looking games with this engine, and it's an engine that has a lot of capability, right? So I'm not sure I like the company, but it doesn't mean that it's not a good engine. Havok is just a physics engine, so it's not necessarily a game engine, and it can plug in, to some other engines. And notice it says proprietary / shareware, right? It says 2018. The last stable release was 21 months ago, and because it's owned by Microsoft, they keep on improving it and improving it. It's not like they have Havok 1, 2, 3, 4. They just keep on iterating on the same engine, which is pretty cool. The Dark Engine. Back in the day, they made Thief, the Dark Project, and so they made an engine around it. Going back to what we said earlier with Dr. Hoag's remarks, make a game, not a game engine. Here's a great example of a game engine that was made for just one game that evolved. Okay. CryEngine. I'm looking forward to Crysis Remastered. To be honest with you, I know some people don't like it. I'm one of those people who does like it. I'm not sure if it's going to come out anytime soon, but it's the CryEngine has made a ton of games, including Far Cry. All right, the original Far Cry before it got bought by Ubisoft was really good. It was really revolutionary in terms of the way it did its lighting and shadows and everything else. A really great game. Back in the day. Now it's changed. They've improved on it, iterated it until now. They're not using the CryEngine anymore for the latest releases. ID Tech. We talked about this and their recent engine. Notice that we're at ID Tech 7, not ID Tech 1. ID Tech 1 was for the original Doom. This is ID Tech 7, the one they used for this new, in my opinion, game of the year, Doom Eternal, right? Which is an awesome game in terms of fun. And they keep on coming up with new stuff for it. Good multiplayer as well. So check it out. It may not be for everybody because it's really, really fast paced, but you can do a lot of stuff with it in terms of modding your controls so that way it works for you. And I think once you learn how to do that, this can be a very successful game. The great thing about this is what it supports in terms of platform. Take a look here. It not only supports PlayStation 4 and Xbox One, but also Google Stadia, which is another thing that's happening nowadays, which is the streaming games. So that's how I feel about it. Can't forget this one, Source. Source was like, I can't tell you how many hours and hours of Half-Life I played when I was younger. And it's something that still has really great graphics. If you actually go play Portal or Portal 2 or anything like that, for what it was back in the day, it was really innovative, right? Especially everything, again, to me, whenever I think of engines, one of the main things that I think about is not just graphic capabilities, real-time graphics, shadows, but the ability for them to take advantage of the hardware that's out there. So, for example, one of the things I'm looking for now in the latest engines that are going to be evolving, are they going to take advantage of ray tracing and the stuff that we're talking about now with the new RTX cards that have been announced lately from NVIDIA? For example, not just real-time ray tracing, but other stuff that they've come packed with. And the RTX 3000 cards. So I buy an RTX 3000 card, but how many video games and how many engines actually support that card? For now, not that many, right? And even the RTX 2000 level cards, the 2080 Ti and so on, have any game engines or games actually been made specifically for that type of card to support real-time ray tracing? And I'd say still not a lot, right? So waiting for that support to come takes years. And when actually they tap into the hardware, that's where game engines can really make a difference and be awesome. And that's what these guys did with Half-Life. They started tapping into the hardware that was out at the time. So a lot of times we see game engines, and the game engines actually are a reflection of the hardware that's been developed over time. Like some of these game engines, they couldn't exist in previous iterations of the hardware because the hardware was just not fast enough. Here's another one, the Decima engine, not to be confused with our Ontario Tech homegrown game that we made for Level Up, Decima. This is the Decima engine that was used to create Horizon Zero Dawn, right? Which is kind of their most popular game. I've also recently played Death Stranding, and I'm not sure if you guys have tried that. It's kind of okay. I think I've talked about it before, but it's and one thing that you can see is they've also extended their support for PlayStation 5, right? So this is pretty cool. Again, notice that we see that name again, Kojima Productions. They've moved away from using the engine that they used originally for Metal Gear Solid, if I can say that, to the Decima engine, which is something they're going to be using going forward. So really, really good. And then finally, I can't not mention Snowdrop. Okay, we have to mention Snowdrop because we have a AAA company in Toronto, Ubisoft, and they use Snowdrop even today. Snowdrop is being used for all kinds of stuff, and I know they've also used other engines, but this is kind of their proprietary engine that's in-house. So one of the last games they used was the Snowdrop engine for was for the Division 2, right? And they keep on making new games from there. So that is kind of a selection of different game engines that you may know about. There's other ones out there too. So think about if you were going to, and these are party thoughts for today. I don't want to go too much more into detail now. I'm going to let you go a little early today compared to normal. Think about Snowdrop and think about other game engines that you see on this list. What's missing? Would there be a game engine that you'd want to talk about or that you really admire, something that they've done as an example? And if you know one, if you're a software engineer or a lead software engineer or someone who loves who considers themselves a game engine developer, right? What have I missed? Think about that one, and let's think about what that game engine has compared to some of the other game engines that we've talked about today. Think about this. Every one of these game engines has their own really cool perks, and really cool, quirks, if you will, as well, that are able to create different kind of games. And one other question I have for you is, do we need all of them? Right? Is it sufficient? Do you think Unity and Unreal can do the same kinds of things that these engines can do? And what do you guys think? Do you think that would I rather have a proprietary engine? Look at all these proprietary engines. Every one of these ones was proprietary. Why would I bother running with Unreal or Unity instead of making my own proprietary engine? And I think, and it's a rhetorical question, and the answer that I have for you is this. If I was a starting off indie developer, instead of writing my game engine from scratch, right? And starting off, yes, it'll build great capability in my team. But if I want to start going with money, if I want to start supporting multiple platforms right away from the beginning, before writing my own killer engine, right? Maybe wouldn't I want to use something like Unreal or Unity so I can get going? Wouldn't I want to support multiple platforms, mobile as a good example, VR, AR that's out there right now? And I think that's the real impetus for us to do that. So one of the things that Dylan says here in the chat is you could put in the work, but some of the companies are large enough that they don't have to depend on Unity and Unreal. And I agree with that, but it takes time for you to build up A, your capability, B, your tool set, and the most important thing, and this is the hardest thing to build up, is resources in terms of developers who know how to do that kind of stuff, right? Kind of to attract a developer in-house to build up an engine, to do things like memory management and graphics, which is, graphics alone is a specialized skill, as you guys know. If you've done intermediate graphics, you know how difficult that course is. And it's difficult because graphic work is difficult, right? So you have to do someone who knows how to do all those kind of things, or a group of people who can work on an engine to make it generic enough that they can make the game that they want to make, but specific enough so that they don't waste their time coding something that they don't want to make, that they don't need. You know, that's the challenge. Whereas out of the box, I can pick up Unreal or Unity and I can go. I can run with it. I can make money, and that's really the reason why Unreal and Unity exist, because not everyone is a game developer that can make a game engine. Okay, I'm going to leave you with those thoughts. So next week when we get together, just to recap, tomorrow I would look for a release of group assignment 1. One thing we haven't done is formed groups. I will also make that capability apparent tomorrow. I will send an announcement that says, hey guys, you need to sign up for these groups. Here they are. I'm going to probably create like these, an area that you can go and sign up for a group. Again, the groups, there'll be 2 types. One, there'll be assignment groups for group assignment 1, group assignment 2, and so on. And another one will be for your project groups. Your project groups will be a totally different thing. That'll be for the larger project that you're going to be working on for me this semester. Okay, and the same one that you're working on, as an example, for James and for everyone else. That project, there are requirements that I'm going to give you to make sure that you have everything that you need to get going, and so that you build them in ahead of time, so that you keep those in mind as you build your 3D game. I'm going to give you those requirements probably tomorrow, so that you keep in mind as you build your game out what it's required, so that way you kind of match up with what I need at the same time as you meet some of the other professors' requirements in other courses. Okay, so look for that. It's going to come out tomorrow. I would have liked to bring it out today, but I'm still working on a couple of things. Like I said, I want to try and balance those things off. And when you talk with Nicholas, you'll have him for the first tutorial next week coming up on Wednesday. Please don't forget to go to tutorial. Okay. Otherwise, if there's no other questions, I'm going to stop recording on YouTube, and I'm going to take questions now if there's any kind of questions or concerns. Thanks, guys. For those people who are watching on YouTube, I'll see you next week.